Hello, AP Calculus students, Mr. Record here, and I would like to introduce you to the first of our videos in a series of solving differential equations and ultimately how we can apply these differential equations to solve real-world problems involving growth and decay. And really the purpose of this particular video is to formally introduce you to the method of separation of variables so that you can solve very simple differential equations. So if you've never seen a differential equation, this is probably the video for you. However, if you've been solving some basic to, say, medium level differential equations, you might find the content of this particular video to be a review. So let's just jump right into it. This is section 5.2 from our course at Avon High School. And basically the introduction to this just kind of explains that up until now, the types of equations that you have seen that have contained a derivative, hence a differential equation, are always ones such that the y prime or dy dx, in other words, the derivative component, is always by itself, right, whether it's a second higher order derivative or not. But the key is that the other side of the equation consists entirely of an expression in terms of x, say some function in terms of x only. But now what we're going to do is take a look at a more general type of differential equation where maybe we have both x's and y's kind of hanging out on the right side of the equation. And that makes them a little bit more challenging to solve. And in order to do so, we have to use this technique that we call the separation of variables. So let's just jump right into our first example. We see our differential equation, an equation with a derivative in it. But the very first thing that I'm going to suggest that we do, and I always tell this to my students, is that any kind of prime notation that Isaac Newton had originally coined, we want to change that to Leibniz notation. In other words, use the differential kind of notation. So we'll call y prime dy over dx. That's going to be very important. Once that's done, you can start taking inventory of your equation and decide, okay, well, what do you have going on the left side? Well, of course, we have x's and y's on the left side, as we do on the right side. So that needs to be addressed. And upon inspection, we see that we could probably multiply the y over to the left side. And at the same time, we could multiply this dx differential term over to the right side. Yeah, in a sense, I am just cross multiplying. And once I do that, I can achieve a separation of variables. Now, this is a basic problem where a simple cross multiplication will accomplish that task, but you'll eventually learn that there are going to be other equations that require a few more steps that will allow you to separate the variables, and I'm sure that we'll have some videos down the line for those kinds of problems. But once we're at this particular step, we start thinking, well, our goal is in solving a differential equation is just really get y alone, or solve for y if at all possible. And that does imply that we don't want differentials hanging around. We don't want dy's, we don't want dx's. And so the only way that we can rid our equation of these differentials is performing the inverse operation of the derivative, which would be the antiderivative. So if you're thinking, put an integral symbol in front of both sides, you're thinking correctly. Now, normally you can just simply add that integration symbol to the previous step to save a little time, but for the purpose of these notes, I'm going to rewrite the step as I did. Now we can perform the antiderivative of the left side, and of course we would get y squared over 2. Yep, there should be some constant, and for the purpose of just this example, I'm going to go ahead and throw that constant in on the left side. This is not going to be the way that we normally go about doing things, as you shall soon see. And if I do the same thing to the right side, if we integrate 2x, I would get x squared. I'll throw another constant on the right side. Now you'll notice that I did put subscripts with my two constants because we cannot assume under any circumstances that they're the same. They could be, but we don't know that. And quite often, they're probably not going to be. So what we're going to do eventually is take care of that by moving the constants completely over to the left side. So if you think about, well, what's c sub 2? Move them over to the right side, apologize. C sub 2 combined with this c sub 1, we can just call simply the constant c. So it's very likely that this step here that I've written probably won't need to show up on your papers as you guys are solving the problems. Just remember to put that constant with your independent variable. That would go with the x, or if, say, in a word problem, that would go on the side that maybe the variable t was used. Okay, now that you're at this particular point, you could proceed to solve for the y as best you could, and that would first involve multiplying both sides by 2, and then this is where it gets a little weird. This is where things get kind of strange, because if you do multiply through both sides by a 2, what do we have when we take 2 and multiply it by c? Well, one would think it would be 2 times c, and it very easily could be that. Or you could think that the c could absorb that 2 and just keep morphing into all of these different kinds of possible constants. And it's really not a big concern of mine that we worry about something like that. And the reason is because this particular problem is sort of lacking some information that's typically going to be provided. In other words, we're going to have mechanisms in place where this c is going to be able to be solved for. And that's really important for a number of reasons. Because if you look at the next step in getting y completely by itself, well, you would think that you would have to take the square root of both sides, which of course is true. But as we take the square root of both sides of an equation, we would have to kind of think about, are we dealing with the plus or the minus here? And the question is, we would really be forced to be looking at only one or the other. So for that purpose, I'm going to kind of decide to write the equation a little differently. I'm going to separate them, and instead of put the traditional plus minus in front, I'm going to separate the two completely, because the answer to our differential equation, ultimately, we want this to be a function, all right? We want this guy to be a graph that will pass the vertical line test. And with that plus or minus sitting out in front, that's not going to happen. But in this particular case, since we were solving for a general equation, a general solution, we don't quite have that luxury. But you'll see in later videos when you do have the specific information that will allow you to decide upon what c is, that is also going to play a role in deciding whether you would use the plus or the minus. Right? For the purpose of this particular solution, I'm going to stop right here and say that either one of these would be okay.